Hi, this is a follow-up video to the problem with the carbon fiber shaft. And one thing I had noted in Bill Southern's video is that when he set the manticore on the ground and folded the coil up against the shaft, the manticore became very, very noisy. And some people have speculated, does the carbon rod actually act like an antenna? And is it coupling EMI into the coil? This looks obviously like a dipole, so seems like it could act like an antenna. But I think there's something else going on here, and I'll demonstrate that. Again, I have an Equinox. I don't have a manticore, but I'm running it on the prospecting mode, which is 40 kilohertz, and it's also a first derivative mode, which makes it a bit chatty and more sensitive. And so you can just listen to right now the idle noise. And I've got the sensitivity cranked all the way up. A little chatty. And so let's set the rod just underneath the center line of the coil, and you can sure hear it's noisy. Nothing's moving. Now, let's see what happens when we lay the rod across the coil. And the result is the same as the idle noise. There's no difference. And so the noise only occurs in this direction, not this direction. The reason for that is because with a double D coil, you have a transmit coil, usually on the side where the cable is. Transmit coil on one side, receive coil on the other side, and you have a center zone where the overlap is that creates a positive target response. So let's say you take a nickel and you get a positive response in the center of the coil. You can't tell it because it's going to give you a response no matter what, but on outside of the center part of the coil, you get a negative response here and a negative response here. And so when I lay the rod across the coil, a little noisy, I'm getting a positive response here and a negative response here and a negative response here. And what happens is those responses tend to cancel each other out somewhat. You still get a bit of a positive response, but not nearly as strong as if you lay the whole rod right down the center line. And so what's really going on here is the rod is creating a very large signal in the demodulators. It doesn't matter whether it's a digital system like the Equinox or an analog system like, let's say, a Goldbug or something like that. You get the same results. So you get this very large signal in the demodulator. You also get a phase shift because, again, this thing looks like salt water, not like ground. And so the phase shift coupled with the amplitude increase makes the demodulator very noisy, very susceptible to any internal circuit noises, say from the preamp or the analog to digital converter, and also very susceptible probably to EMI. So yeah, in a sense, this might be amplifying EMI, but not because it acts like an antenna. It's because it's pushing the demodulators into a much noisier area than their idle state. You can demonstrate this by simply taking a coin. In this case, I'm using a nickel, but probably a quarter or anything else will do the same thing. And we'll just place it right on the overlap. And it gets noisier. Let's try a quarter and see what happens. Oops. Much noisier. again, we're pushing the demodulator into a static area that is far more noisy than its intended static area, which is no signal at all, or maybe just a ground signal. And so the noise issue isn't because of an antenna effect with this. It's because of the way demodulators work.